Thank you. So I'm sorry that I haven't been really present in these videos. Well, this is like my second video and my last upload was like last year. But I think I'm getting the hang of it because last year I had a lot of things to do. I was like sec 2 and like studying had to be number one thing I had to do, so I had to neglect some things and responsibilities. Well, that kind of took a toll. Right now I am in upper sec, which means that I'll probably not be doing any more of those lower sec videos, but I'll be continuing this channel journey with some upper sec videos. I'll probably continue teaching like combined sciences. Right now I'm taking combined science of chemistry plus physics. So that's been quite fun. Okay. I take EMATS, POA, combined history and social studies, along with like my normal subject like Chinese and English. So if you have any questions on that or you want me to upload any like of the videos or like studying things, I'll be happy to do it. When it comes to upper sec, sec 1 and 2 lower sec things, but I'll probably not do it again because I kind of need to focus on my O levels too. It's like kind of recap for me. Anyways, let's get started, shall we? So right now, today we'll be doing Science Chemistry Chapter 1, Measurements and Experimental Techniques. Before we truly get started, I think I really recommend you head down to like my bio to like click on this like certain like Google Drive link or Tiny URL link. I'm not sure what I'll be doing in the future, but yeah. Click on it because it has like a worksheet that you'll be doing, because right now we're doing this like fill in the blanks MCQ things. I think it'll be better for you that if you really try them on your own before things. Well, just see how this goes. I've never done this before. I hope you support. Okay, let's start. So our first part is experimental design and instruments. So let's start with the basic one. So these mass, beam balance, electronic balance, time, digital stopwatch, all these quantities and instruments you should have learned when you were in lower sec. But these few will right now be actually learning in a more like detailed manner. Because now these are like in our syllabus now, so we actually should learn more things. Okay, let's start. Okay, first question. Can read these sort of things first. Like burette will reads to two decimal places used in I can't say the word. Teritations. A pipette will deliver a fixed and accurate volume, for example 20. But usually these actually fixed volumes will usually be at 25 cm. I'm sorry if that's a bit incorrect. Gas range will read to its nearest cm squared with a maximum of 100. So this gas range was actually used to be using to measure the volume of gas, as stated here. Okay, so let's start in our fill in the blanks. Okay, to measure the mass of a substance, we use over here we see beam balance and electronic balance. You actually have to use the very scientific term, even though it's like a bit annoying, but it's like what science has to do. Now that you're on I actually learn like a lot of things. Oops, sorry. Okay, maybe in like when you're in the website, you don't have to be so specific. Oh my god, my typing terms. Oh, that be so specific, but now that we're on the site, you actually have to like, even with 1 mark questions, you have to write like a long paragraph. It doesn't make sense. Okay, to measure time, we use a digital stopwatch. You can't just write stopwatch like this. This will merely give you a 0 on streak. You have to write in a more specific font, even if it's just a 1 mark question, because those actually matter, and science doesn't give you half mark questions anymore. Okay, so a burette will give readings to two decimal places as stated here. For example, I'll write as 20.55 as stated, I put it here earlier. But you can use any other numbers if you like. Okay. A pipette is used to deliver a wide volume of liquid. So actually, as stated earlier, that a pipette, actually, this is what a pipette looks like. So while other diagrams, they have like let's say the burette and the measuring cylinders that we already know, they will have like markings like one like here, and there. But for a pipette, there only be one marking of 25. If that makes sense. I'm sorry if it doesn't make sense, but it's okay. Okay, so a pipette is used to deliver a fixed. Okay, so The volume of gas is measured with a watt with a max capacity of 100. So as stated here, volume of gas is only one, called the gas syringe. So I'll type here gas syringe. As like the other scientific terms I stated just now, you can't just write syringe because you have to like, it's like not the real scientific form, that's like the basic term. You have to write in a more like specific term. It's annoying, but it's what I have to do. So it's 100 cm square. Cm cube, sorry. I've lost my thing. It's okay. A boiling tube is used for what? Small amounts of liquid. So actually a boiling tube is used for heating. I stated the word boiling there. It's like common sense questions, but it's okay. We are learning them on the way because science is not common sense anymore. Okay, so let's start with our first practice question. A student wants to measure exactly 25.0 cm cube of hydrochloric acid for titration. Which apparatus should they use and why? So before doing every practice question or like every like open-ended question, you have to always check on the amount of mark allocation there are. Because those are actually important. It's like saying, and like when doing your mother tongue, it's like if you write if there's like 1 mark, you must write 1 point. This one is just like basically the same thing, but you have to keep an eye out for keywords. So the first answer would be the pipette. So I mean the first question would be, why is a pipette? Remember to read the question carefully, okay? A student wants to measure exactly 25.0, as I stated just now, here. This is what a pipette will look like. Well, without the red drawings here, it will be like, oops, sorry, didn't need that. It will be like this. This is what it will look like. It's so hilarious sometimes, but it's okay. Okay, so the pipette, right? So you have to ask why. So you have to state in like the very scientific term, like in normal times. A pipette delivers fixed and zero. Oops, sorry. 25.0 cm. I want to write like gosh, the cm cube thing because like it's actually important and it's basically math, but with more things. I don't know what I'm talking about, but I didn't get a point. And measuring cylinder one. Okay, if you don't get the hang of it, that's okay, because I didn't get the hang of it when I started, but it's okay. So a pipette delivers a fixed accurate volume. We know about this because stated here, it delivers a fixed accurate volume with greater precision than a measuring cylinder or burette. If you don't want to write precision, you create as actually like alternative words you can use. Like precision, instead of precision, you can write like instead of precision, I'm not sure. You can write like it's in decimal points or DP, whatever you call it. Then I think there are other ways, but I'm not quite sure. But it's okay. We'll stick to this answer because precision is the most scientific term that I can think of right now. Okay, so it's the only difference between a burette and a measuring cylinder. So obviously, look back at the mark question again. It's only worth 1 mark, but you still must write both because it's asking you to state the difference between both of them. So you must state what are they both about. So let's write the first answer. Okay, so a burette, state burette first. A burette reads to 2 decimal places and delivers variable volumes accurately, whereas measuring cylinder reads to only 1 decimal place and it's less. Okay, so the first question would probably be, I thought you're only asking about one difference. Why are you stating two? Well, if you're writing in like this like sense, as I already said earlier, I think that science attribute the most important thing is to be precise. It's to be accurate and like it's okay to write like one extra thing, like it's like a side note if you're really scared of the answer. That's like a small exam tip with the WA. If you don't know the question, just skip the question. It's actually really fine. Okay, so when you take a break, you can always pause the video, whatever. Or if you want to try the questions out by yourself, it's also possible. You can just like pause the video. It's literally a video. It's not live or anything. Okay, so let's start. Okay, part B, collection and drawing of gases. So these three are actually like quite new, especially these few. Okay, so you'll be learning like the more exact version like chemical bondings, etc. in like the future chapters, but right now I'll be learning about collection methods and how we collect it. So you can just read through first. I'm not sure there's much to explain. Okay, displacement of water is for insoluble gases in that are obviously in water. Downward delivery are for soluble gases. Soluble gases that are denser than air. Okay, upward delivery are basically gases that are soluble or less dense. Okay, so actually these two are they are, as long as the word like soluble is there, that means it usually has to do with one of the deliveries, just to measure like which one is like the denser one. Okay, then displacement of water is as long as the gas are in water or are insoluble or both. It's probably displacement of water. These are like the basic things you know. I think pure science has like more stuff, but I'm not taking pure science, so I have no idea. So these are also like some notes you can write about. So I think these things that we're not really learning, I crossed it out. Sorry. Don't think we're learning this, so I can just cross this out. But these two are like the, how do I say this? They are like the very like complex things that I don't think that even I can teach you. So if you have any questions about that, ask your real teacher. I'm a fake teacher. Okay. So okay, first question, gases are insoluble and water are collected by, as stated just now, as long as they are insoluble and in water, it's probably displacement of water. So let's write displacement of water. Okay. So ammonia is collected by what delivery because it is what than air. So let's check for ammonia. Is it here? Yeah. So it's collected by what delivery? So it's soluble. So soluble about deliveries over here. Downward or upward delivery stated here is less than, so it's upward delivery. Because it is less dense than air. Okay, so next to CO2, also known as carbon dioxide, is collected by what delivery because it is what in water and what in air. So actually it's collected using downward delivery, as you can see over here. Downward delivery. Oops, sorry. I didn't realize the downward delivery there. Downward delivery because it is soluble in water and denser than them. To dry chlorine gases, we use what? Because chlorine is a what gas? Okay, so to dry chlorine gases, we actually have to use concentrated things. So it's like concentrated. I think it's the H2SO. But, well, oops, wait, stage tested. Oops, I think I'm lagging. It's okay. To dry chlorine gases, we use concentrated because chlorine is acidic, I guess. My bad. I think I'm sleeping already. These things are just tested. But it's like not like the real term, just had to know about like the acidic and alkaline gases for now, I think. I forgot my sentences. Okay, so CaO should not be used to dry CO2 because CO is a what oxide? It's actually a basic oxide. And CO2 is acidic. Okay, let's stay over here so you can just take out the notes a bit. And they would probably react contrast to each other. I think you'll learn this more when you're in like the future chapters, but these are like some things that you might want to know. Oops, can you see the word? I hope you can. Oops, just do this real quick. It's okay. You get it. You'll get it. It's okay. Okay, so next question. Explain why calcium oxide is not suitable for drying action for CO2. Number. We have 2 more questions, so we need to write 2 points. So let's first write our first point. Why? So let's say the CaO first. Is a basic oxide. Oh, CO. I don't think I can write that now. Because CO2 is an acidic. I'm sorry, my grammar is a bit wrong, but it's okay. They react. Which visualization is it here? Visualization to form. Okay, so actually these are things that you'll learn in chemical bonding, I think, or atomic structures. One of them, or probably both. So you don't actually know this right now, but it's okay if you want to know like a bit ahead. Gas would be removed. Just try. Okay, so I'll just be a bit brief before I turn very specific on like other topics. So actually see all these sort of things, right? Neutralization, I think you'll learn somewhere in chemical bonding probably. So I don't need to know this right now, but it's okay if you want to just know for a while. Okay, so a student collects a gas using displacement of water, but the gas is partially soluble. Suggest what errors this causes and how they should have collected it instead. Okay, so the question is asking about collecting a gas, right? But the gas is partially soluble. Just now we have stated that only insoluble can give displacement of water. So what should have been done? I'll give you like a minute to think about it real quick. So let's answer the question. You can pause the video to think. That's okay. Some of this gas dissolves. So the volume collected is less than expected. Oh, where'd you go? Sorry. Expected. Making results. Making results inaccurate. Wait, sorry. I'll see a bit inaccurate. Student. They never said who was a short student. Should use delivery of what delivery instead. But sometimes, if you want to be a bit more safe, like maybe if you're scared, like, cause it's a 3 mark question, obviously, you're a bit scared, teacher won't give you like the mark or anything. You can just write like if like in like bracket form, yes. So then delivery. What delivery is obviously less dense. Okay, so just write this for a while. I'll like leave it here for a bit. Very long. Okay, good enough. Good enough. Okay. 8 more times pause the video. Okay, next part. Part C. Ooh, I hate this part. It's like a lot of words. Okay, let's do this. Okay, so I think you're gonna make a read through first. So a mixture is two or more substances that are not chemically combined. But a pure substance is a single, so it's let me find like a way to try to show you. I think you already learned this in like lower sec, but it's okay, it's like a bit of a recap. Okay, so basically this is like what a pure substance would be like. This is what a pure substance, pure substance, pure substance. But if you add in things like it's called zero color, okay? Add in things like this, like mixtures already. They're like mixtures, you know, like everywhere, you know. So I think that this could be like one of those things that you all might need to have a small recap before like learning the new chapter, which really is havoc. Okay, so filtration is insoluble. You can just read through like everything. I think like most of these things we learn in when we're in lower sec. So well, like chemistry is basically like a recap of like everything in lower sec for the first few chapters, and then it's like new stuff. Okay. So just read through these sort of things first. Boiling chits to ensure smooth, even boiling. Thermometer board. I don't think that I think we need to learn about the thermometer board for now. Then oops. Where's my reverse? So you can just like read through everything while I did this. It's okay. Just edit this. It's okay. I did this. It's okay. Actually, I need this. Wait, maybe it's better like this. Sorry. Okay, So let's continue with our fill-in-the-blanks question. Infiltration. Liquid passes through paper is the filtrate. You can just read throughout from and the solid left behind is the residue. Okay, so obviously they are two different things. So it's like this like the diagram. Then we'll have like these sort of things. So like downstairs over here, there's like things here. And there's also like things over here. Okay, so actually this is like the filtrate, I think. Let me check. Yeah. Okay, so this is like how it's like gonna be when you're doing like filtration through filter paper, which probably doesn't make sense now, but it will make sense much later. Okay, crystallization is used when the solid is what? When the solid is not what to heat. It's not actually heat stable. Okay, it's a droplets, but actually like one of like the less scientific forms. But we'll be using it to like help you to explain more. Because sometimes when you learn from it, you must learn like the basic terms before using the scientific terms. Because like you get confused sometimes. Okay, sublimation separates this NH4Cl from Fe2O3 because NH4Cl can wow FeO3. Okay, that sounds a bit wrong, but this is like your chemical thing. So a sublimation can what? So a sublime. Well, Fe2O3 cannot sublime. Okay, basically. Sublime basic meaning is like solid. It's like you have like for subliming it will be solid to gas directly, but like if you cannot sublime usually it's like you have to like go through the steps, so I must go like gas, liquid, solid. But sublime is just gas immediately solid or solid immediately gas. It just works that way. Okay. In separation funnel, the what denser it sinks to the bottom. So obviously we know that dense usually means that it has to be like how do I say this? When it's like dense, you have to like it's like going down, so it's obviously denser. Cool water enters the condenser from the what? From the bottom. To keep the jacket completely what? Providing efficient cooling. So if we're doing from the bottom, it must always be filled. Okay, let's start our practice questions. Yay, I think it's like our part D is next, so yay, okay. So the next question. The student has a mixture of sand and sodium chloride. Describe the steps to obtain pure dry sodium crystals. Okay, so actually we can write this in like, I mean, you're supposed to write in like paragraph format, but I'm not taking my exam now, so I can just write in the point forms. So first step is to add water and stir. So known as NaCl. Okay, dissolves. Sand does not. Okay. Step 2 is to filter it. Okay. So the sand will stay as residue. NaCl solution process is filtrate. Okay. Maybe you understand this now, but you probably understand this when you're a bit like more experienced in the chapter, like learning more from like your textbook or teachers. Okay, so here. So heat filtrate until hot. Saturated solution forms and allow to cool, which also means that NaCl crystals form. So the fourth step is, fourth step is always remember to filter to collect the crystals. So like we're doing these sort of things, actually I learned from like practical, you actually can must have to pat down with filter paper. I think you'll learn more when you're doing practical, but like this is like the rough sense on how it's gonna go. Okay, next question. Explain why sublimation is suitable method to separate NH4Cl from Fe2O3. Okay, so let's start. Okay, so actually NH4Cl, oops, 4Cl can sublime. it converts directly solid to gas when heated. Condenses back to. Let me change real quick. Sorry, OCD a bit. Condenses back to solid on the cooler inverter. The cooler inverted funnel. So Fe2O3 cannot sublime and remains in the evaporation dish. So must say like what will you do? So you must separate them two. How's what that P-R. Oh, it's A, sorry. Separating the two. Okay, so I'm writing it like NH4Cl, but I'm typing it. So like if it's actually happening, there's right, and like the 4 can't be beside it, it must be like here. Okay. Like remember where to put the 4, like the numbering. Don't put it beside it. Beside it completely wrong. Don't want you guys get the wrong answer, okay? Give you guys a minute. Okay, you start. Let's go. Part D, chromatography and purity. So here is used to separate solutes that dissolve in the same solvent. The working principle is solutes with higher blah 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 blah. Okay? Okay, I think I already gave you the answer for this, but these are like the basic things. It's okay. So actually these steps you actually need to memorize. I know, right? It's like so annoying. Sorry. Wait, that's a bit crooked. You can just read through everything first. It's actually you need to memorize this, especially at the steps. And like this is actually important. I had it for you. This is actually important. Because sometimes the questions will actually ask you why must you draw like the start line with pencil, and it's like really annoying, but you have to write why. Because pen ink will affect results. Okay, and that's probably because graphite does not dissolve in the solvent, which is also important, fortunately. So these are like all the things you need to know before like we really do the paper and things. Okay. Okay, let's do this. Chromatography is a pure substance that shows one spot if impure. Melting point, pure solid, and sharp, blah blah blah. You can just read on your own pace and whatever. Give you guys a minute. All good? We're talking like random persons. Okay. Okay, let's continue with the fill in the blank. So RF equals the distance traveled by substance. Divide by distance traveled by the solvent. Okay, this is how you need to like know what the RF is. The start line must be drawn in the pencil. See, as I said just now. Because it does not dissolve. I think. Dissolve? Doesn't matter. You'd be surprised that science doesn't actually care much about like the spelling. Just get like the rough idea can already. Okay. The solvent must be what below the start line to prevent samples dissolving. Right. For the color substance, a what agent? A locating agent. Agent is used to make spot visible. A pure solid has a what? Actually has a sharp and fixed point, melting point. A substance is likely pure if it what shows spots. If it shows only one spot, because obviously here I already said that it will only show one spot. If it's impure, it will show only one spot. So that's how you test. Like, so if the teacher asks you like all MCQ questions like, oh, why is it one spot? Blah 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 blah. Just tell them this. That's cause like if it's like one spot, it's only pure. But if that's like 2, 3, 4, then it's probably impure. Okay, also that. Okay, let's continue. Okay, so a dye spot travels 4.2 and the solvent travels 6.0. Calculate the RF and comment on what is a good value. So actually, these kind of questions will actually come out. So let's start. RF equals to 4.2 divided by 6.0. Why should write 6.0? Because that's actually important. Because like if you write only 6, then they'll probably mark you wrong. Because I'm asking for 2, like 1 decimal point. You only give me 1 sig figs. That doesn't make sense, okay? So 4.2 is the substance divided by distance traveled by the solvent. So it's 4.2 divided by 6.0. Sorry, 6.0 will equals to, which calculator for this? 2 equals to 0.70. You must write in the 2 sig fig number because they've been writing in 2 sig fig and it's probably not the correct reason. So you have to comment it because also 3 marks question and they asked like what it was. So let's comment it a bit, shall we? This is a good RF added acid within the range. Oops, there you go. Maybe. What? Sector range of 0.500 to 0.80, indicating the separation. Okay, so actually this kind of thing you actually don't really need to. Oops, why is it? Oh, sorry. See, this kind of things you actually don't really know. For now, I don't think you need to know this, so you can just like put this out for a bit. Okay. So explain why a lid is placed over the beaker during paper chromatography. I still can't say it to this day. Okay. So let's say it is to prevent solvent from evaporating. Oops. Evaporating if the solvent evaporates. Solvent fan stops moving, giving inaccurate RF gas. So actually this thing I'm not sure if it's tested for now because my teacher didn't really teach this. I just learned this from my tuition or something. So you can just read this as like not tested for now. But you can just ask your teachers if it's tested. I'm not a teacher stated. I have like a teaching degree. I'm just a student. I'm stage 3. Okay. Okay, so actually in the next few pages that we'll have like an MCQ session that will actually like learn all things. So I think I'm gonna take a pause for a bit. And I think I'll probably like take like a 5-minute-ish break. Let's see questions. Okay, there are oops, don't look at the MCQ please. Okay, there are 8 questions. I think I'll go through questions. Well, I think I'll just go through questions 2, 4. Yeah, I'll just even number questions already. Maybe just should we just 2, 4, 6, 7. Okay, so these questions I'll go through. I'll give you like maybe like 5 minutes to do the questions. Take a gauge for 5 minutes. Like if you have like 4 questions and like depending on like overall standard, it's probably best if you take like 1 minute per question. But it's okay to overrun a bit, so that's like a bit of buffer time. Okay, I'm just gonna like take a pause. So I'll kind of like stop the video, walk through the questions. Give me like 30 seconds. Okay, so let's do this. Okay, let's do this. Okay, got this. Got this. Almost there. This video is marked for 34 minutes. Okay. So ammonia gas collected by an upward delivery because it is A. Insoluble and less dense. B. Soluble and less denser than air. Soluble. C. Soluble and denser than air. D. Insoluble and denser than air. So actually the correct answer, I think it is B. Okay, the question is why B? Because some people got it wrong. Okay, the answer is B. Oops, maybe I shouldn't put that. Let me just like put it over here. Okay. Okay, so it can't be A because A is actually soluble because displacement of water can't be used. C is denser. If it's denser, it should use downward delivery, not upward delivery. If it's not D because NH is insoluble and actually wrong. Ammonia gas is soluble, not insoluble, so that obviously be wrong. So if we cancel the options, the only answer possible will be B. Okay, so let's continue question 4. A student needs to separate visible liquids with different boiling points. Which method should be used? A. Simple distillation. B. Fractional distillation. C. Filtration. D. Separating a funnel. So actually the correct answer would be, once again, B. Should put here probably. It's probably safer. Sorry. Could be, okay. So if I use simple distillation, because simple distillation will usually mean liquid from a non-violet solute, not for two miscible liquids. C is not because filtration equals to insoluble insoluble solid from liquid, which is the completely wrong method here. Okay, we call it separating funnels because separating funnel will usually mean immiscible liquids only. So we cancel everything out, it's usually B. Okay, question 6. Let's go. An RF value of 0.25 suggests the substance A is very soluble in the solvent, B has reliable good result, C has low solubility in the solvent, D is impure. The answer would actually be C. Okay, it's not A because if it's very soluble, it will have a very high RF. It will be close to 1 and not 0.25. Okay, it's not B because a good RF will usually become from 0.5 to 0.8. 0.25 is below that range, which is not ideal. Okay, it's not D because RF value alone does not tell you about purity. The number of spots does. Okay. Okay, let's see this question. Okay, I hope you understand what I'm talking about. I really hope so. Question 7. Which observation about the melting point indicates an impure solid? A. Melts at temperature higher than expected. B. Melts sharply at fixed temperature. C. Melts over a range below the expected melting point. And D. Does not melt when heated. Okay, so actually the answer for this question would be C. Answer would be C. This reason because A. If impurities are lower than melting point, it will not raise it. It's not B because a sharp fixed melting point will usually mean a sign of a pure substance, not impure. It's not D because not melting suggests a different substance of decomposition, not just impurity. So the answer would be C. Okay, so the other question you can try by yourself. You can ask like AI or something to explain to you why the reason will be. Okay? Let's go. Open the questions. Yikes. There's like a lot of stuff here. Okay, so I'm gonna go through questions. Let's see what's nice. I'll go through questions 1 and 3. Yeah, I'll go through questions 1 and 3, and then I'll give you all like the answer key for everything. Okay? Sounds good. Or you can ask like, wait, yeah, I should just go through everything. So I can just go through everything. Okay. Never mind. Okay, I'll give you guys like 10 minutes to do these kind of questions. Especially like question 1 and 2, like those are priorities, okay? We'll take like a short 30-second break. Y'all can like take a pause or everything. Just take a like a breathe or something. Okay? Okay, let's do this. Let's do this. Okay, first question. A laboratory has a mixture of ammonia chloride, NH4Cl, and sodium chloride, NaCl. Describe a method to separate and obtain a pure sample of each substance. Include the apparatus needed and a working principle of the method chosen. So let's start with the answers, okay? First, you have to heat the mixture gently. Gently in an evaporating dish. So the NH4Cl sublime, or sublimes also can, from a solid to gas, and condenses on the outlet filter funnel placed above. Okay, so what I like to do is I like to like separate my things so it's easier for me to like see any of my spelling errors or whatever. Okay, so NH4Cl is collected from the funnel as pure crystals. So NaCl remains in the evaporating dish. Okay. To obtain your, I always forget the term for this, NaCl, ATL, you have to dissolve, meaning solid in water, filter if needed, and evaporate YT to dryness. Okay, so this is actually the main answer that you're looking for. Let's open-ended 2. A student runs paper chromatography on food dye. The spots are at 2.0, 3.5, and 5 for the line. The solvent fund is 6.5. So let's start question A first, okay? So actually from here, now I got 3 different spots, which means I actually have got 3 different components, okay? So I can write for question A. The food dye contains 3 components, 1 spot. One spot per component. Okay. Part B. Calculate the RF value for each of the component. Okay. So let's do this quite simple. Okay. So let's say for the first one, we'll write 2.0 divided by 6.5, which eventually does to 0.31. Okay. Next one will be 3.5 divided by 6.5 equals to, what up? Sorry, I came to. Divided by 6.5, which is 0.5. Then next one will be 5.0 divided by 5.0 divided by 6.5 equals to 0.77. So we're actually dividing everything by 0.6.5 because the solvent front is 6.5 and we're measuring based on like the, because RF value is like above right, everything, okay? So this will be our 3 answers. So remember to like label them like this is my answer. Don't just put everything on one line, okay? Because during this course I'm like computer typing everything out. Okay, next question. Part C. Which component is the most soluble in the solvent? So actually it's the component that travels the furthest. So you actually have to write like which one is it, so you have to things right. So it's the component that traveled the furthest is the most soluble in the solvent. Okay, so in this case, right, if you're quite scared, cause the mark allocation is 3 marks, so naturally become 1 mark per part. But if you're more scared, you can always write like the side is like, that's right, I can write the furthest is the most soluble, so the furthest is like 5.0 cm, but the RF value is, I think it's 0.77. Okay, I can write this down also. Okay, question 3. Should I got everything? I'll just do everything. Okay. Question 3. A chemist needs to purify copper to sulfate crystals contaminated with insoluble impurity. Describe fully how crystallization can be used to obtain pure copper to sulfate crystals. Explain why evaporation or dryness will not be suitable. Okay, so let's answer the question. So I'll write in like the like these type of point forms, but you have to write in like paragraph form in your real exams, okay? So first step would be dissolving contaminated. Contaminated CUS. Contaminated in hot water. Where are you going? Okay, question step 2. First you have to filter. Filter to remove the insoluble impurity. Okay, this is also known as what you like to call the filtrate. Okay, so you can write this down like filtrate. Okay. So you can write like, cause like filtrate is actually the scientific form. If you'll be surprised, filtrate is the scientific and basic term, but it's just working like that. So filtrate equals to CuSO for solution. Okay. Step 3. Heat the filtrate to form a hot saturated solution. Then pour at room temperature the crystals were actually formed. Oh, I step, sorry. Skip the number. Okay, step 4, you have to filter to collect crystals and pat dry. Okay, so actually important thing that you need to know that during your practical sessions that you probably have, this is actually very important because you actually need to really pat dry them with your actual finger. It's like really disgusting a bit, but it's like something you have to do. The filter paper will actually be like a paper, but it's like inside has a little cloth-ish inside. So you'll feel very soggy, but you'll feel like very like constrained because you already know like what the filter will feel like. So if it's sand, I think that's why I define practical. Sand, you actually feel like the actual sand particles, which is actually really cool. Because you actually see the difference in like the residue and filtrate, etc. Okay. So let's see. Oh, because sorry, I've got another point. Okay, because the question is asking about explain why evaporation dryness will not be suitable. Do you have to write like expand more? Cause you have to write like so. Continue here. Evaporation to dryness is you have to write say this by the way. It's unsuitable because CO4 is heat sensitive. It loses water. Citation on strong. I can't spell it. On strong heating, giving a white powder instead pure blue crystals. You can actually sort this out actually. Because crystals are for like science, they are usually like blue, which is actually true by the way. Okay, so you have to write evaporation dryness is unsuitable. You must explain why. Even sometimes some questions you have to actually check based on like the amount of lines they have. If it's a lot of lines, usually means you need to explain by yourself even without them asking you. But if only has one line, just write the answer can already. Probably most of the time. Depends if teachers are nice or not. Okay. Okay, next question. Explain the purpose of the fractionline column and glass beads in fractional distillation. Why is fractional distillation preferred over simple distillation for separate ethanol and water? Okay, so let's write. The fractional, it says the fractionating, wait, hold up. Fractionating, I think, sorry, I forgot my things for a second, provides a large surface area for heated condensation. Condensation, sorry, and evaporation of vapors. Okay, continue. The glass beads will actually like increase like the amount of surface area. Making evaporation, making separation more sufficient. So let's have separation more efficient. So actually simple distillation is not suitable. So I write this wrong, right? Sorry. I mind like spelling errors for now. Because like I'm quite like flow state, so I need like to check it out first. So it's ethanol is usually 78 degrees Celsius if I'm not wrong. I can't write this on March smart yet. In water have similar boiling points. The distillate or there you go. Mixture of both. Okay. So actually fractional distillation separates completely. Sorry, I just did some off camera like typing things. Let's write this down first. Okay. So let's finish this last question. Open-ended. Yay! Last question. Let's go. Open-ended. Question 5. Substance X was tested 3 times. Melting point recorded was 78, 81, and 80. The standard melting points of the pure substance 83 degrees Celsius. What conclusion can you draw to justify your answer? Okay, my conclusion I can draw is substance X is impure. Why? Because his melting points are all completely different. I mean they're similar, but they're still different. If it was pure, everything would be the same. Okay. Let's write it down in a more scientific form. Recorded melting points below the standard and vary over a range rather in a single fixed value of sums. Both are signs and impure substance. Okay, so let's read through real quick. Okay, so you can take your time to pause the video at any time if you have any questions. Okay. So we just finished the whole worksheet. For MCQ questions, sorry, I couldn't finish everything all, but the answer key is actually right here, so you should answer. Yeah, they're mostly C and B, sorry. Okay, just should answer when everything's okay. And that probably marks the end of chapter 1 my teaching for today. Yay! So it's a good thing to be back, and yeah, I hope to make more videos. So bye for now.